So to do this problem, first we have to figure out how long the truck travels. So it's given that it goes for 1000 miles and at a speed of v mile per hour. So it goes, black pen. So mile over velocity is the time, so this is the hour. Now it's given that the cost of fuel is 6 plus p square over 50 gallon per hour. So this is the amount of fuel that is spent. So this is the total hour times the, in order to find the cost, this is the total fuel used, and times 0.5 is the cost of the fuel. So this one will be one part of the cost, which is the fuel cost, plus the driver's wages. So that's $20 per hour, so 20 for each of them. So 2 times 1000 over B. So this should be C. So if we calculate this one, so it becomes 500 P 6 plus P square over 50 plus 4000 here, 40,000 actually, V. So this one becomes 3000 V plus 10 V plus 40,000 V. So if we add it, it becomes plus 43, and this is what we need to prove. So the first part is proved, which is question 1. Now second one says the truck must not take no longer than 12 hours to complete the trip, and speed limit requires that V has to be less than 100. So we have to find the speed so that the cost is minimum. So in order to do that, first we have to find the minimum cost. So we should differentiate these things. So dc over dv, and we will equate it to 0. So if we differentiate this one, this is 10 minus 43,000 p square. This is the differentiated one. dc over dv is this. So from here we get v square is 43,000. So v is 4310. Now whether this is a minima or maxima, in order to find that we should find dc dv square. So this one becomes, since dc, this part is dc over dv, so if we find the second derivative, it becomes negative negative, so it becomes negative, then negative 2 times 43 v cube, since this was v to the power 2, and if it is differentiated, then this thing v to the power minus 2 becomes minus 2 v minus 3, so minus 2 over v cube. So this is what exactly what's here. So this minus becoming plus 86 v cube. Now if we plug in the value v43 here in this d square c dv square, we obviously can see it will become a positive. So this is, since the second derivative is a positive, it is a minimum. So that criteria fulfills, it's a minimum. Now one thing before concluding that this is the speed at which the truck has to travel to minimize the cost, we have to also consider the time constraint. We have to see whether if it goes with this speed, how long will it take. So in order to do that, I will erase this part. So we know that it has to travel 1000 miles and the speed we saw was 43. So the time it will take will be 43 over 10. This is the speed at which it can go that will minimize the cost. That is fine. However, we also have to look at the other constant, which is it can no longer drive more than 12 hours. So once this is the hour it will take for the truck to reach to travel 1000 kilometers, at this speed, and we see that if we do the division, it becomes something like that. So it is more than 12 hours. So this one is not acceptable because of the time constant. So we have to redo this one considering t is equal to 12, and then this should be the time it will take, and this one we will use to find the velocity. So v is becoming 1000 by t, which is 1000 over 12. This should be the velocity that with which it will travel, because it travels at a constant velocity, which is v miles per hour. So this is the velocity with which it will travel, and then we can find the minimized cost by just plugging in. I won't do that part anymore. So 10 times this much, 12 plus 43,000 over, so it becomes 1000 here and 12 here. If we calculate it, we will get the cost in dollars. That's fine, but here the trick is just we have found the speed which will minimize the cost. That's fine, and that was this speed, but because of the time constant, this speed is not allowed. So we redo this thing to look at what speed will let the time constant remain there, and it won't exceed the 12-hour limit. So then we find the new speed, and then we calculate the cost.